Hello, welcome to Secrets of Geology. My name's Brooke and I'm a geologist. So in our last episode we took a quick look at some rocks and I showed you ways that we can read those rocks and then interpret them to understand about how the Earth has changed over the billions of years of its existence. And we did that just by looking at rocks that we found in Oxford High Street here in the UK, or the rocks that you can find wherever you live. In this episode though, we're going to look at one of the most fundamental parts of Earth sciences, and that's understanding the age of the Earth and the geologic timescale. Understanding the geological timescale and the vast amounts of time that have passed since the formation of the Earth are absolutely key to understanding all the changes that have taken place since the Earth formed 4.5 billion years ago. Learning 4.5 billion years worth of Earth history might seem like a daunting task, but I guarantee that you actually already know more of this than you realise. Because there is so much Earth history to try and understand, I'm not going to try and cover all of it or even half of it. What we're going to do today is learn some key points in time and some key concepts that are going to give you a frame of reference to help you understand other things we'll talk about later on in the series. You're probably familiar with terms like Jurassic and things like dinosaurs, but there's a lot more to Earth history than just big lizards and supercontinents. Ignore him, it's fine. This is going to be an interactive exercise so you can join in at home, or wherever else you are. So we're going to start off with a finger on our chin. This is our 0 point. Our chin is about 4,500 million years ago, and this is the formation of the Earth. As we travel along our arm, a small planet the size of Mars face plants into the Earth, destroying the early crust and creating our moon in the process. So after the moon impact, the crust starts to cool down and solidify again. We get ocean basins forming, degassing from the core, and a lot of that gas is water vapour, and it starts to rain for hundreds of millions of years, and eventually the oceans fill up. And then we get down to here, in our stinky gross armpit, about 4,000 million years ago. This is where life starts. Our next major point in time is about 3,500 million years ago. That's around about the middle of your bicep here. Is that your bicep? I don't know, I don't study vertebrates. It's at this point that we start to find sedimentary structures called stromatolites. By the time we do see early life, basically bacteria, those bacteria are already pretty well evolved, which means that they must have appeared somewhere back down here in our armpits. Just after our mid-bicep, there's another biological breakthrough that will change the world forever. One particular group of bacteria learned to harness sunlight to make food. They evolved photosynthesis and start to produce large quantities of a gas called oxygen. And the world is changing beyond recognition at this point. All of that oxygen has gone up into the atmosphere. The thing about oxygen is it's very, very reactive. So reactive I've completely forgotten what I'm supposed to be saying. This world-altering event is known as the Great Oxidation Event, or sometimes the Great Oxygenation Event, or GOE for short. Pretty much everyone just calls it the GOE. Because the cyanobacteria and the oxygen removed all of the carbon dioxide and other greenhouse gases from the atmosphere, firstly the Earth cooled down so rapidly that there was a catastrophic ice age we call the Huronian Ice Age. This is an ice age that was so severe there might have even been sea level ice at the equators. So in other words, it was brass monkeys everywhere. But nothing much changes until we get to round about here on our upper forearm. Something very interesting happens here, and the first eukaryotic cells appear. Eukaryotic cells are those cells that have a nucleus and internal organelles. Eukaryotic cells are everything that you would think of as being complex life, and that includes everything from everything from microscopic amoeba and fungi through to gigantic plants and a kind of mostly naked ape that learns to take apart the universe and put it back together as video cameras. So what happens after eukaryotes evolve? Well, actually, Bit embarrassing for eukaryotes, but not an awful lot between here and here. And about 1,300 million years ago is when the rocks that I study were deposited. They're called the Roper Group and found in northern Australia. And I'll talk about them in detail in another episode. We're round about here now, just at the top of my tattoo. And this is about 1,200 to 1,100 million years ago. It's at this point we start to see some more interesting fossils. Eukaryotes are starting to do stuff now. They're starting to make little tiny shells for themselves, which look like the shells of modern testate amoeba. Go and Google them, they're cool. Also, we see some kind of spiky and scaled forms, and these things are still really tiny, less than a fraction of a millimetre, but for the time, they're incredibly advanced. About 1,000 million years ago, or 1 billion years if you prefer to count that way, and we start to see the first true multicellular organisms that you can see with the naked eye, although they're still quite small, and that's red algae, seaweed. The atmosphere at this time is still pretty low in oxygen, but the oxygen level's starting to creep up and up. We're now here at the very bottom of our hand, so we're going to zoom in because a lot's going to happen in a short space of time. About 800 million years ago, that's absolutely catastrophic globe-spanning glaciations, similar to the Huronian glaciations that happened earlier. There's a lot of argument about whether these glaciations actually did reach the equator and whether they did freeze over the whole sea and turn the Earth into a snowball. But regardless of whether there was a snowball Earth or not, these glaciations were immense and lasted for hundreds of millions of years. So round about here, in the middle of our palm, the megaglaciations end and we enter what's called the Ediacaran period. It's also at this time that the first macroscopic fossils appear of creatures that you could call animals. Some people contest that fact quite strongly, but recent biomarker evidence has shown that at least some of these creatures were probably early animals. We're now here at the top of the palm, and this is the boundary between the Precambrian and the Phanerozoic. Prior to this, the Earth is dominated by microorganisms. After this, the Earth is dominated by things like animals and plants that you can see. I say dominate, bacteria still rule everything, but you know what I mean. It's at this time that creatures with shells and hard parts start to diversify rapidly, sometimes called the Cambrian explosion. So things like snails, arthropods, all kinds of shellfish appear, and the ancestors of what will eventually become vertebrates like us. A little bit further up, maybe it's just a millimetre on our palm, and the first land plants start to spread out over the Earth. At the end of the Ordovician, there's an absolutely catastrophic mass extinction, and we're into the Silurian period now. So fish are starting to look like fish. The sea is populated by trilobites and orthocone nautiloids, lots of other weird creatures that you might not recognise. Things are starting to diversify on land. We start to find the first body fossils of plants, these little tiny bryophyte liverwort looking things called Cooksonia. So we now enter the Devonian period, the age of fishes. Fishes really start to look like what you'd expect a fish to look like at this point, but also you still get loads of really cool weird ones that look like armour-plated monsters. You start to get the first terrestrial vertebrates. Also we get the first forests, the first trees. Before this, plants had just kind of stuck to the top of rocks. Now trees with roots started to pulverise the rocks and break them up, and the fact that they were dying where they were living created soil, and that changed the input of nutrients into the sea. And this may have led to the next two mass extinctions, which both occurred at the end of the Devonian period. We are into the Carboniferous period, the period of the coal swamps. Terrestrial vertebrates are really taking off at this point, not literally though. We start to get the first reptiles in the Carboniferous period, and also some very giant arthropods like Meganeura, a giant 70 centimetre dragonfly relative. We're now into the Permian period. Pangaea, the supercontinent that most people are familiar with, is fully formed. Much of the Earth's surface is a desert, and reptiles are widespread. Towards the end of the Permian period, there's an absolutely catastrophic mass extinction, the largest one so far, known as the Great Dying. Something like 95% of all life in the sea becomes extinct, and it changes the face of the Earth forever, again, for another time, but more so than the last times. So here we are in the early Triassic period. Dinosaurs are starting to diversify rapidly. The first pterodactyls appear and the first mammals appear. Towards the end of the Triassic, Pangaea starts to break up and there's another mass extinction. We're now in the Jurassic, and in the early Jurassic, Dinosaurs diversify rapidly along with marine reptiles and ammonites and other staple creatures that most people who are into geology and fossils will already know a lot about. It's at this time that the South Atlantic starts to open in, and there's another minor mass extinction known as the Torsion-Anoxic event. We're now in the late Jurassic and the first birds have started to evolve. The South and Central Atlantics are well and truly open, and Gondwana is starting to separate. Here we are about 140 million years ago in the Cretaceous period. Flowering plants and modern trees have evolved and are starting to spread all over the world. But terrestrial ecosystems are still mostly ruled by the dinosaurs, with mammals living squirreled away. Do you see what I did there? Squirreled away in little hidey holes. But mammals are still diversifying and evolving as well. Now we're in the late Cretaceous, about 70 to 65 million years ago. Most of North America is flooded. Gondwana is completely separated, and chalk seas are covering vast areas of the flooded continents. About 65 million years ago, a giant rock face plants into the Yucatan Peninsula. About 65 million years ago, a giant rock from space called Chicxulub face plants into the Yucatan Peninsula and causes a mass extinction, probably the most famous one. Little recompense for the dinosaurs and the ammonites. So now we're into the Cenozoic, the age of the mammals. From here to here, the modern world starts to emerge. And then round about here, the very top of my fingertip, is the last few million years. This is where the first hominins, the things that you can call humans, start to appear. And then just a little bit further up, a millimetre or so, we have the ice ages. And then finally, here, right on the very tip of my finger, all of human history. Everything that you could consider a modern human, including all written history, going back hundreds of thousands of years, it's all there. It would be a line that's too small to see at this scale. You could just rub it out like that, and everything we've achieved is gone. Cool.
4.5 billion years worth of Earth history in the length of your arm. I wonder how many of you realise just how little time humans or even animals had been around. It puts into stark perspective just how much humans have changed the world in the fraction of a % of Earth history that we've been around. But no matter how much we do change the surface of the Earth through our actions, the Earth will be here long after we're gone, and the only trace of us that'll be left is some strange geochemistry in a very thin layer of rock. I know that some of you might find that a bit bleak, but I actually find it really comforting. After everything that Earth and life have been through over the last 4.5 billion years, I know that no matter how much we mismanage this planet, Earth and its life will survive. So thanks for watching. I hope you've enjoyed this video. I'd like to hear from you now. In the comments below, let me know which part of Earth history surprised you the most, and was there something you wanted to hear about that I didn't mention? Until next time, like, subscribe, find us on the social media and share this video with your friends, and take care. Bye bye!